Region Pimata from BSED Math 2A, and in this video we will tackle about the area between curves and line. So let us have an example. Find the area of the region bounded on the right by the line y is equal to x minus 2, on the left by the parabola x is equal to y squared, and below by the x-axis. Okay, first thing that we will do or we must do is to sketch the graph. So we need to sketch the graph first to identify if it is our solving is correct or if our area is correct. Okay, we have the equation and y is equal to x minus 2, and we have also the x is equal to y squared. So this is the parabola and this is the line. So let us sketch. So the graph will be look like this one, so use your GeoGebra. We have 1 here, then we have 2, we have 3, and we have 4. Okay, so since our values in our y is positive 2 and yung isa is y is equal to negative 1, so we have the upper limit and the lower limit. Okay, so the graph will be look like this one. We have negative 1 and we have here 2, this one. So the graph would be look like this one. This is the line, so we have here y is equal to x minus 2. Then the curve or the parabola will be like this one or look like this one. So as you can see, there are two intersections here. So the curve in the line intersects. So here is the coordinates here is, since we have y 2, then here we have negative 1. So as you can see, they are aligned. So we have 1 and negative 1. So we have here 1, and we have here, since it is to our y-axis and the x is 4. So our x-axis is 4, as you can see. Diyan, gagaling. And our y is 2. The same with this one. We have here x and our y. Okay. So the area of the region, is equal to 9½ square units. Okay, this is the area. So we will check this one if this correct or not. Okay, so the area of the region will be here. This is the area of the region, or the area of the region between the curve and the line. So this is the area. Okay, next is we will identify the integrals and then solve or combine and conclude. We have two equations here. The y is equal to x minus 2, which is our line, and the x is equal to y squared, which is the equation of the parabola. So by additive inverse, we have y plus 2 is equal to x, and we have x is equal to y squared. So we have y plus 2, which is this one, y plus 2, then the y squared. So our x-axis is the x-axis is our remaining variable. So we have here y plus 2 is equal to y squared. Then by additive inverse, we have y squared minus y minus 2 is equal to 0. Then the factor out po natin. So we have y minus 2 and y plus 1. So equate into 0, we have y minus 2 is equal to 0. So we have y is equal to 2. Then y plus 1 is equal to 0. So we have y is equal to negative 1. So we have the values in our y variables. So we have the upper limit and the lower limit. So our lower limit is negative 1 and our upper limit is positive 2. And then, integrate na natin. So using that 1, so we will integrate that 1. Okay, so the definite integral of the negative 1 to 2 of y plus 2 minus y squared dy. So we will use this formula. So to find the area of the curves and the line, we have to follow this formula, or we have to use this formula. So the area is equal to the definite integral of a to b times the f of y minus g of y dy. Okay. So we have here. Then we can integrate this one, the y plus 2 minus y squared. So we have our y squared over 2, this one, plus 2y, since our variable is y, then y squared will be y cubed over 3. So we will use the power of integration. So we will add 1 here. 2 plus 1 is equal to 3. Then divided by 2 plus 1, we have 3. So 2, then let's add a variable y. And then y, 1. So we have here the imaginary exponent. So y, 1 plus 1 is 2. Then divided by 1 plus 1 is 2. Okay, integrate natin sa negative 1. And to substitute the values of our y. So our y, we have 2 squared over 2 plus 2, then our y is 2, minus our y is 2, so 2 cubed over 3. Minus, since our formula is this one, so we need to subtract. Okay, so we have negative 1 since our lower limit is negative 1. We need to subtract the upper limit and the lower limit. So lower limit is subtracted to the upper limit. So since we have negative 1, so we have negative 1 squared over 2 plus 2 negative 1. We will substitute the values of our y here in our variable y. So we have negative 1 minus negative 1 cube over 3. Okay. So 2 squared is 4 halves. So, or 2. Then 2 times 2 is 4. Then 2 cube is 8 over 3 minus, since minus, the negative 1 squared is positive 1 over 2. Positive 2 times negative 1 is negative 2. Then negative 1 cube is, add natin kasi negative times negative is positive. So we have negative 1 cube is positive 1. Negative 1. So, negative 1 times negative 1 is positive. Then, over 3. And then, we have here 2 plus 4, 6 minus 8 over 3 is 10 over 3. Then, minus 1 half minus 2 plus 1 over 3 is negative 7 over 6. So, 10 over 3 minus negative 7 over 6 is equal to 9 halves square units. So, if we will find the area of the curve, or the between the curves and the lines, we will input these units or square units. Okay, so that's all for today. Thank you.